Hi, welcome to this first in a series of videos that we'll be using in this course, namely MATH2002, Mathematics of Finance. In this video, we will look at simple interest. Let's start with a very simple scenario. Here we have John, and he's borrowing some money from, let's call him Mr. Banks, and he's borrowing $100, and he promises to repay in 1 year the amount of $105. Note that at the end of the year, he'll be paying back the original $100 plus an extra $5. So you can think of that $5 as a fee being charged for using Mr. Banks' money. This extra $5 is going to be called interest. So the total repayment at the end of 1 year is going to be the principal that he borrowed, which is $100, plus the interest, which is $5, which gives us the $105. So we need to find symbols for these terms. So the total repayment at the end of 1 year, we will call it S. The principal, we'll call it P. And the interest, well, we'll use the symbol I. So there are many names that we can give this symbol here. For now, we can call it the amount, but it's also called the future value. Sometimes it's referred to as the accumulated value, sometimes as the maturity value. And over here, this is called the principal, which is the original amount borrowed. But as we'll see later on, sometimes it's referred to as present value, discounted value, proceeds. So for now, we'll just settle on calling this the amount and this the principal. Here's an example we can use to exercise what we have just discussed. So Mary borrows some money. At the end of a certain period of time, she pays back a total of $7,300. So that's the amount, right? That's the total payment. So S is equal to $7,300. And the interest comes up to $475. So that's $475. So the question is, how much did she originally borrow? So we know that the amount is equal to the principal plus the interest. It should be very easy for you to just simply make the principal the subject of this expression. That becomes S minus I. That's going to be equal to 7300 minus 475. So she originally borrowed $6,825. So that should have been easy. Let's take a deeper look at what's going on here. From John's perspective, he's getting a loan. But from Mr. Banks' perspective, he sees this as an investment. He's buying something. He's buying an asset whose value grows. And how much is it going to grow? Well, at the end of the year, he will have made $5 because John will have to repay $105. So this asset that Mr. Banks bought, and it's not something physical, it's like an abstraction, its value grows, and it grows linearly. So it starts out, let's suppose this is just 1 year, so it starts out at with a value of $100 and ends up with a value of $105. So we could write that in here. So again, remember, with simple interest, the value of the asset, of the investment, grows linearly. So let's modify the situation a bit. Let's say John borrows $100 for 6 years and agrees to pay $5 interest for each of those 6 years. So now this goes from 0 to 6. So now this is year 6 more or less over. That's year 6. I can't draw this very neatly on my computer. That's a straight line, guys. And so what will be the value of this asset? Well, if it's making $5 every year, it starts out at $100. And the answer to this then should be very easy. It should end up at 130. So this should be a straight dotted line coming down here, guys, to mark the 6 years. We can look at this process using a table, a spreadsheet. In this case, I used Excel. So over here, I placed the principal, which is $100, and John borrowed this money for 6 years. At the end of every year, how much interest was due? Well, since this is simple interest, every year the interest is the same amount, $5. Of course, for 6 years, this adds up to $30. So let's look at how this grows. At the end of the first year, the asset has grown from 100 to 105 because it made $5 interest. Then it grew by another $5 at the end of the second year. So every year it grows by the same amount. So if we're to look at this growth in the value of this asset, in the value of this loan from Mr. Banks' perspective, we can see we get linear growth. It's easy to see that as a percentage, the interest here is 5%. Every time it's calculated as 5%. So it's 5% of 100, then 5% of 100 giving us $5 every time. Notice, however, if we look at the accumulated value, this $5 does not represent 5% of the accumulated value. So for example, by the time this interest is being paid over here, this one, then 5 of 115 is not 5%, but rather if you do the math, it's 4.3%. 5 divided by 115 times 100. And of course, by the time we get to this last interest payment is 5 divided by 125, which turns out to be 4%. So this interest represents 4% of this value. That's 4%. But always it's representing 5% of this value over here. So every time in simple interest, the interest is the same amount because we are always calculating it as a percentage of the principal and not as a percentage of the accumulated value. This will change when we switch over to compound interest. So I'm only mentioning it now so that you are prepared. So later on we look at how we can do this in Excel. This is fairly simple to do and you should all be able to do this. So the numbers that I use for this example, it should be easy to see that each year the interest is 5% of the principal. Simply divide 5 by 100. Calculating the interest rate per year, let's use this symbol for the annual interest rate. We simply divide the interest for that year, in this case it's $5, by the principal, and that gives us the interest rate, the annual interest rate, which typically is expressed as a percentage. So we would simply say then it's in this case 5%. In this example, we have that Mr. Banks loaned his friend $1,400, so the principal is $1,400, and 3 years later got back $175. $1,775. So the interest for those 3 years then is $375. So how do we calculate the interest rate? Well, first we have to find the interest for a year, because what we want to do is calculate the annual interest rate. So this is so it doesn't say it here, but this is the annual interest rate. So we calculate that by simply saying, well, we need the interest for a year. It was 3 years, so the interest for a year is going to be 375 divided by 3 divided by 3, and whatever we get for this, we divide it by the principal. So we can do that by simply putting it down here again. So let me just write it over here this way. Divide all of that by the principal. So notice that's going to be 375 divided by 3, that's 125, divided by 1400. That gives us then 0.089, or roughly 8.9%. A little refresher here. This looks rather ugly. If you remember your basic arithmetic, what we're saying is 375 divided by 3, and then that result we're going to divide it by 1400. So we can write that as 375 divided by 3 and then divided by 1400. So we multiply that underneath here. That's a multiplication sign. So let's take a look at this again. What we did is first we found the difference between the loan and the accumulated value. And that gave us the total interest. Then we needed to find the interest per year. So we divided that by the number of years, which is given as t. So that's I over t. And then of course once we get this, we take this and divide it by the principal. So we have this. So in other words then, the annual interest rate is the interest divided by the principal divided by the time, the number of years. Of course we can write this like this if you prefer, which is what we have here. The interest is equal to the principal times the annual interest rate times the time in years. We have a formula for the interest, so now we can easily get a formula for the amount or the accumulated value. We know that the accumulated value is going to be equal to the principal plus the interest, but the interest is equal to the principal plus the annual interest rate, times the annual interest rate times the number of years. If we take out common factor p, we are left with S equal p times 1 plus RT. So this is very important. Make sure you know this well. In many problems you are given the principal and asked to calculate the accumulated amount. But you can also be given the accumulated amount and be asked to find the principal. in which case then the principal is simply the accumulated amount divided by 1 plus RT, which is what we have here. It is more common, however, to express this in this fashion. So make sure you understand this. This is making use of the fact that any number a to the minus 1 is equal to 1 over a. So if p is equal to s times 1 over 1 plus RT, then that's like saying s times 1, this is an s, plus RT to the minus 1. Often when you're given problems, you won't be given the problem in terms of a number of years, but rather in terms of a number of months. And so, for example, if you have 12 months, that's 1 year. So t is always found by dividing the number of months by 12. This means that if you have 18 months, that's going to be a year and a half, 1.5, 18 divided by 12. Now, if the time is given in days, if you want to get that in years, you, strictly speaking, should divide by 365. However, in this course, we'll divide by 360 as this is the common practice. By dividing by 360, this number, of course, is going to be a little bit bigger than if you divided by 365, which acts in the bank's favor, because then t will be a bigger number, so the interest will be bigger. So just keep this in mind. So when we use 365, we say we are calculating the exact simple interest, and when we use 360, we say we are calculating the ordinary simple interest. So that's pretty much it for this lecture here. Here are some problems for you to work on. I got them from page 20 of your textbook, so you can go there and look for the solutions. Alright, so that's it for this video.